This is Trig Quiz 3 review. Number 1 says determine whether or not the mean value theorem applies to the function f of x equals 4 minus secant x on the closed interval from negative pi to negative pi over 3. If so, find the value of c as defined by the theorem. If not, state the reason why. So in order for mean value theorem has two conditions. Function has to be continuous on the closed interval and differentiable, meaning smooth curve that the derivative exists on every point on the open interval. So if we look at this function here, secant x, if we think about secant graph, secant is essentially the reciprocal of cosine, and so secant is basically 1 over cosine. And if we think about 1 over cosine of x, cosine of x is equal to 0 at pi over 2, at negative pi over 2, and negative pi over 2 falls on the closed interval from negative pi to negative pi over 3, so therefore there is a break in the graph, meaning that the function is not continuous over the course of this interval. So what that means is that the function is not continuous on the closed interval because of the vertical asymptote. Mean value theorem does not apply because we need the two conditions to pass in order for mean value theorem to apply. All right, number 2, determine whether or not Rolle's theorem applies. So Rolle's theorem has the first two conditions of mean value theorem, but then the additional condition is that the endpoints have to have the same y value. And because in Rolle's theorem, we're trying to guarantee a very specific slope of the tangent line, and we're trying to guarantee a slope of 0 for a tangent line, for a tangent to a point on the curve. So that's why we have that third condition. But let's think about sine of 2x. So sine of 2x is going to be continuous everywhere, and we know that x is also continuous everywhere, and both terms are going to be differentiable as well. The derivative is going to exist at every point on the graph, so there's no breaks in the graph, and the function is differentiable. So we can just go ahead and state those terms: continuous on the closed interval, differentiable on the open interval. If so, find the value of c as defined. So both conditions pass. We just need to find the endpoints. So we need to plug 0 and 2 pi into the original function. So sine of 0 plus 0 is equal to 0. Sine of 2 pi plus 2 pi. So sine of 2 pi is 0 plus 2 pi is 2 pi. So mean value theorem would be able to work, but not Rolle's theorem. So Rolle's theorem requires the endpoints to have the same y value. If the endpoints do not have the same y value, we're not able to guarantee a slope of the tangent line somewhere between the two endpoints being a slope of 0. So therefore Rolle's theorem does not apply. All right, number 3, determine whether or not mean value theorem applies. So in this case, sine of 2x plus x, same thing as number 2, but now we're not trying to guarantee Rolle's theorem, we're just trying to guarantee mean value theorem. So again, we talked about the first two conditions already passing the test. So it's just the endpoints. So the endpoints is 0, 0, and 2 pi, 2 pi. So we can, with mean value theorem, we're trying to set the derivative function equal to the slope of the secant line. So we're trying to figure out, is there a point on the curve where the slope of the tangent line matches exactly with the slope of the secant line? So we need to first find the secant line secant line slope. So to find slope of the secant line, we do change in y over change in x. So 2 pi minus 0 over 2 pi minus 0. So that gives us 2 pi over 2 pi, which is 1. So we're trying to guarantee a slope of 1 somewhere on the curve. So what we need to do is next find f prime. So f prime is find the derivative of this function. So sine of 2x becomes cosine of 2x times 2. We have to go through chain rule. So cosine of the derivative for sine of u is cosine of u times u prime. U prime is the derivative of 2x plus the derivative for x, which is 1. So we have our derivative. Next, we set our derivative. I put the coefficient 2 in front. I set the derivative equal to 1, and then we can just now solve for x. So when we solve for x, subtract 1 from both sides. 2 cosine 2x equals 0. Divide 2 on both sides, so cosine of 2x equals 1. So we can convert this out from under the double angle theorem property, and we can convert this to 2 cosine squared x minus 1. We set this equal to 0. Try to solve for x. So add 1 to both sides, divide by 2. So cosine squared of x equals 1/2. Cosine of x is equal to plus or minus root 1 over 2. And then plus or minus root 1 over 2 is the same thing as root 2 over 2. So when is cosine equal to plus or minus root 2 over 2 between 0 and 2 pi? It'll have 4 instances where cosine is equal to plus or minus root 2 over 2, which is in the first, second, third, and fourth quadrant. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And notice all 4 of these c values fall on the open interval between 0 and 2 pi.